Good luck. Yes, you can grab your correct finding. Okay. So yesterday we were talking about this idea of stoichiometry. And stoichiometry is just a big fancy word for if you have this much of this, how much of this. That's all it means. Every single stoichiometry problem will always involve the two words molar ratio. Because the molar ratio relates one thing to another. Now, what I want to be very clear about is in any reaction at all, you good? Okay. Sorry, I know you're helping him. In any reaction at all, the coefficients represent just the relative amounts. This many moles of this relative to this many moles of this. That's all it means. So we can always make a molar ratio. In fact, we need the molar ratio to relate the amount of one substance, the chemical amount, to the amount of another substance. When? Yeah, if they're in there. Go ahead, take a look. I don't know if they're actually in there. Nope. So, okay. Actually, that's a good point. This is not actually 7.1. This is 7.2. So can we all do that quickly, please? That's 7.2, gravimetric stoichiometry. I don't know why. I titled it 7.2, but then, like, I titled the actual kind of file on the computer 7.2. I don't know. So you're looking for 7.2. You got it? Did I put in the wrong? I think I put it in the wrong folder. Yeah, I put it in the blue bin instead of the purple bin. Sorry. Okay, so we are always going to need the molar ratio. Anytime I'm giving you something about one thing and then something about another thing, then we need the molar ratio. I know that we said we would do something kind of fun today, but we're not going to. I just was too busy last night. I had a meeting that went for like 3 or 4 hours. So I didn't have time to go grocery shopping, but we will do like a fun kind of stoichiometry exercise tomorrow. I promise you that. I swear on something. I don't know, whatever. Something really important. So was the moles to moles ratio pretty straightforward? Yeah. I mean, when I look at this molar ratio, okay, Idris, can I bug you? Yeah. Okay, it's only because I know you're tough and I know you can handle me picking on you like a big old bully, okay? Or a tiny little bully, I guess. Okay, so I've got my molar ratio here. What does the molar ratio convert between? What are the two things it converts between? So the molar ratio is a conversion factor. It converts between one thing and another thing. Moles of something and moles of another thing. So this molar ratio, it's a conversion factor. It allows you to convert between what two specific things in this molar ratio? Hydrogen and HCl. Moles of hydrogen and moles of HCl. So that's the way the molar ratio works. It's always moles of something versus moles of another thing. So if I give you mass, can I use the molar ratio to convert mass? No. You have to find your way to moles somehow. That's the key idea here in stoichiometry, is 2 moles of this for every 1 mole of this. And that's a critical step. We did a bunch of moles to moles things yesterday. Blah, 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 blah. There were so many there. There's 3 or 4 extra problems that you can do if you want to. But then we started doing one. I think we did, just one single mass-to-mass stoichiometry. Now let's kind of recap this. Our question said, What mass of zinc sulfide could react with 21 moles of oxygen to produce zinc oxide and sulfur dioxide? Okay, so we had this reaction, whatever. It's just some reaction, doesn't matter. And it's asking us, what is the mass of zinc sulfide if I give you the moles of something else? Can I jump? Can the molar ratio allow us to go straight from moles of one thing to grams of another thing?
No.
No. The molar ratio allows us to convert from moles of one thing to moles of another thing. So in stoichiometry, you always need to or will be allowed to convert to moles. Oh, well, once we have moles, yeah, whatever. Luke's fiddling around with his zipper or something like that. No, it kind of sounded like you farted. That's all I care about. Yeah. So I know you didn't because I saw you fiddling with it, but that's fine. So it allows us to convert from moles of one thing to moles of another thing. But if we want mass, what's that missing link? What's the missing link between moles of this and mass of this?
Molar mass.
The molar mass. Again, the molar mass is a conversion factor as well. What does the molar mass allow us to convert between? Grams and moles of that one particular substance, right? So we can, it doesn't matter. You can do stoichiometry as complicated or as simple as you want. All you have to do is be able to get the moles of this thing, convert it into moles of that thing, and then convert it into whatever the hell you want. Okay? Here we want mass, so we need a molar mass. Okay, no problem. I'm just going to ask you one more question. Are you okay with this idea of we've got our reaction and below the reaction we put the values of any information related to that particular substance? Are you okay with that? Yes. I find it allows us to kind of really organize our thoughts, and it makes it a lot easier to just grab information and plug it into the stoichiometry unit analysis. So we're going to do another one. And then we're going to make it a little bit more complicated here in a second anyway, so that's fine. Sodium metal reacts rapidly with water in a single replacement reaction. What mass of sodium metal must react with water to produce 0.540 moles of hydrogen gas? What's my first step in stoichiometry?
Write the formula.
Yeah, you need to write a balanced chemical equation, so the first thing you need is the formulas, right? What two things do I have reacting with each other?
Sodium metal.
Sodium metal. Go ahead and write down the formula for sodium metal. That was the best Mr. Walton expression I've ever, the best Mr. Walton impersonation I've ever seen in my entire life. Did you hear that?
Yeah.
Yeah. So I said, go ahead and write it down. And what Akua did was she turned to Maddie and she said, does sodium metal have a charge? That's the best impersonation I've ever seen in my entire life. I don't know, does sodium metal have a charge? No. Okay, so sodium metal is going to react with what? Water. Okay, formula for water is pretty straightforward. This is tough for some people. This is going to be really tough. Go ahead, and I'm going to give you 30 seconds to try and figure it out. HOH. Yeah. Idris, you're on the right track, right?
Okay.
Because I have water reacting in a single replacement reaction, it's a great idea for us to actually write it as HOH. Now, the reason why that is remember, you can think of water as being like two different parts, right? There's the first hydrogen, which kind of is like a proton. It's kind of like a hydrogen ion. And then well, if the H, that first H is a hydrogen ion, what's the OH going to be? A hydroxide, right? You can think of this as a positive and a negative. It's not, it's a molecular compound, but it'll help. So what's the sodium going to kick out here?
Hydrogen.
The positive hydrogen, right? So you're going to get sodium, whoa, that's terrible. You're going to get sodium hydroxide. And you kick out the hydrogen, and so what does it become? Nope. Just hydrogen. Right? It's going to become an element. Because this is a single replacement reaction, element plus compound gives compound plus element. So what's the formula for hydrogen?
H2.
H2, because it's an element. So now we can use Hofbrinkel. Okay, so what do I have to do in order to balance this?
Still minus
Yes. Good. That is fantastic. How many? Okay, one sodium, one oxygen, one oxygen. How many hydrogens? How many hydrogens? 3. So 2 and 3 don't go together.
Double
So
everything.
double the other stuff, okay? So what I would do, okay, is I could maybe go back. And I would say, okay, so you got 2 hydrogens here. Well, in order to kick out 2 hydrogens, I would have needed 2 of this, and 2 of this, and 2 of this, and that should work out pretty good, right? Let's think about it in terms of front hydrogens and back hydrogens, okay? So front. Let's think about this. How many front hydrogens were kicked out in order to make H2?
1.
2. 2 hydrogens had to be kicked out. Okay? So what I mean by that is for every one of these molecules, yes, you're totally right. We can only pull out one front hydrogen, right? We can only pull out one front hydrogen for every water molecule. But we made H2, so we needed 2 of these in order to make that. Does that make sense? We needed 2 of these front hydrogens to make H2. Well, that means we had 2 hydroxides, so we needed 2 hydroxides. And because we had 2 hydroxides, we need 2 sodiums. And now we're all balanced. Does anybody want me to explain that in a different way?
Yes.
Okay. So that's totally fine. What I'm going to do is I'm going to underline that front hydrogen, and I'm going to try and do like a visual representation of how this balancing act works. So what's going to happen is the sodium is going to kick out 1 hydrogen, right? Now, if I kick out a single hydrogen, then I would only be left with 1 hydrogen, correct?
Mm-hmm.
But how many hydrogens did I need to kick out?
2.
I needed to kick out 2 hydrogens. Well, I can't kick out both of these hydrogens because what would I be left with?
Oxygen.
Just an oxygen. So that I can't do that. So the idea is that, well, if I needed to kick out both of these hydrogens, okay, then I needed at least 2 water molecules in order to make hydrogen. If I were to take a look at what water looks like, so in order for us to make hydrogen gas, right? In order for us to make hydrogen gas, I needed to combine a hydrogen from this water molecule and a hydrogen from this water molecule. And that would have given me hydrogen gas, and I would have been left with 2 hydroxides. Does that kind of make sense? Yeah. Okay. So regardless, this is our balanced equation. So we have kind of a completed first step. Bring your attention back up here, okay? It's okay, I know that was a long explanation, but bring your attention back up here. What's the kind of the second half of the start of our problem? What do we have to do right now?
Write information.
Yeah, we want to take all of the bits of information that we can, and we want to write them below all the substances that they belong to. So read through this question, and I want you to put your information below here. Go ahead and do that. So, when I read through the question, can you confirm for me you only really see two pieces of information? Right? Okay, so I see two in the question. I see what mass, so we're looking for mass, if we produce 0.540 moles of hydrogen gas. But we're missing something here, right? Not missing something, we're just not seeing it yet. What are we not seeing? We're not seeing the molar ratio. You can always have the molar ratio. The molar ratio is something over something. What is it? It's good. The moles of the unknown, the moles of the unknown substance over the moles of whatever is being given to you, right? So just anywhere on your paper, you can put it below or whatever. You can say 2 moles of sodium for every 1 mole of hydrogen gas. And sometimes I like to put in a little box so that it's really easy for me to find. I like to say that it doesn't belong to water, it belongs to the whole reaction, right? It's just a general ratio. Okay, now let's think about this for a second. I'm being given the moles of hydrogen gas. Where can I go from there? Just look at our information. Once I have the moles of hydrogen gas, what can I do? I can use the molar ratio to convert between moles of hydrogen and moles of sodium. So I can get the moles of sodium. Once I have the moles of sodium, what else do I need to get the mass of sodium? So you need to find the molar mass of sodium. The molar mass of sodium is 22.99 grams per 1 mole. And we could say of sodium, right? Now we're ready. Again, I want to be very honest. Do you have to do that whole setup part? No, you don't. You don't have to do the whole setup. You can jump straight into stoichiometry. If you're the kind of person who can work it all out in their head because you want to go really fast, that's totally fine. I'm just trying to warn you right now that you introduce a lot of problems when you don't write your thoughts out on paper. So step 2 is just unit analysis. What are we looking for? We're looking for the mass measured in grams of sodium. Is there anywhere in here that has mass in grams of sodium? The molar mass. 22.99 grams of sodium for every 1 mole of sodium. This is probably going to be the last time I say it, but I really, really, really don't enjoy when people write a molar mass like this, 22.99 grams per mole. Why do I not like that? Yeah, because then people say 22.99 grams per mole divided by 1 mole of something, and then it's just like, oh my god, what the hell is going on with your units, right? It becomes really difficult to figure out you're dividing inside your dividing, and then it becomes really difficult. So just make sure if you see a fractional unit, just write something over something. Okay, so I need to get rid of moles of sodium, so I can use my molar ratio. 2 moles of sodium for every 1 mole of hydrogen gas. And then I can get rid of moles of hydrogen gas using the information given to me. Can everybody check their calculator? Double check that you get 24.8 grams. Because last time I did this problem was 2 years ago. And I don't know.
Yeah, that's right.
Yeah, that's right. Good. So what I would like you to do right now is I would like you to do some practice. And so there are 1, 2, 3. Yeah, go ahead. Do the next 3 problems. So start off with the reaction, put all your information, and then do the stoichiometry. I'm going to be wandering around, and then we're going to move on to something a little bit more complicated. We'll use like gummy and stuff like that.
Oh.
Yeah. Yep. Calcium is a group 2 ion. It does not. How do I know calcium is a group 2 ion? Because it's in group 2 up here.
What were you doing?
I said it was don't.
Yeah, Maddie. Am I gonna have this problem next semester too? Goodness gracious. The answers are all there for all those problems, right?
Yeah.
Yeah, in the black box. Okay. Let me know if you have any questions. Yeah.
Okay, this is what I have now.
Okay, so what? It's not calcium carbonates and calcium hydroxide. It's calcium carbonates. Calcium hydroxide. Yeah, it's so the question hydroxide with carbon dioxide. So basically what's happening is this is your reaction. It says calcium hydroxide with carbon dioxide to produce calcium carbonate and water. So that's your reaction. It's this calcium hydroxide plus carbon dioxide gives you calcium carbonated water. Yeah. And then it just says what mass of calcium carbonate, so you're going to put an M question mark, and this many moles of calcium
Oh,
hydroxide.
they just think about things together. Okay.
Wait a minute. Just give me a second.
Oh, it's carbon. I thought it's dioxide.
That first question, it's got the full reaction in it, right? The full complete reaction is there.
What did you put for the seed of water for that? Oh, gas, right? Yeah.
Okay. Time balance.
Maddie, I've heard this 8 times.
So
Go.
let's think of it. What's the
Okay. Okay. Which one is I doing again?
You don't go
Or no,
right.
which
What
one?
time do you
Oh,
get?
wait, I can't wait.
calcium? How many?
Oh, I think it's just that. Oh my God, were you ready?
How do we go over it?
Turn on the fire.
That's what I said. Sorry, that was really complicated. I still thought
You can tell he's finishing.
it was well.
And you too much of that behind.
Okay. That first equation is already balanced, right? When you just write it out, you just add up all the carbons on each side, they're equal. Add up all the calciums on each side, they're equal. You don't have to balance it.
No, it's 4.
Dude. That's hydrofluoric acid may be produced. How many moles of hydrofluoric acid? How many moles of hydrofluoric acid? So what's happening is you're getting H2SO4 plus
Two.
That's a very
O2, O2, O3, He said it's already balanced, right?
Yes.
Thank you.
One second.
Thank you. Oh.
Yeah, it's already done.
Don't take too long.
How many calciums are on the left hand side? How many calciums are on the right hand side? Okay, that's good. How many oxygens are on the left hand side?
What is
Never mind.
Hey, you were so mad at me, and then. This one? Calcium carbonate?
I touched this, find it.
It's already balanced for you.
I had your wallet, so find this.
Yep, I agree. I 100% agree. So what's happening
You broke
here
that one.
is the carbon dioxide. The carbon dioxide is gaining a hydrogen from here and turning into carbonate. And so the oxygen and the calcium get transferred over. The calcium and the carbonate combine. And then you're left with just two hydrogens and the oxygen. Like, if I could draw a picture, it would look better, but I don't want to take the time to draw a picture. So, yeah. Don't get bogged down in that particular reaction. Just write the formulas. It's already balanced. It's a 1-to-1 ratio. Aaliyah, does it not get Did you have a special program, something going on at lunch? Or?
No, I just don't.
I get it. Oh, you'll get it.
That was a little French.
Yeah.
I already. Oh.
Sulfur dioxide. They're both non-metallic, or they're both on this side, so if there would be two sulfurs, it would say sulfide and dioxide. But I don't. What? On the opposite of the gas. From
I just won't write it.
First 70 questions. Sulfur is burned and produce sulfur. Sulfur is burned in the air. So what are you going to react with sulfur with? Sulfur dioxide.
Okay, this is right. Oh.
Producing sulfur dioxide. So now you just have to balance. Sulfur dioxide gas. Yeah. See, and you wouldn't know that. That's a good thing to add in. For the next time.
I don't know either. Do you number of moles of oxygen? How do you start?
It should be 4
Okay.
instead.
I did write this here.
Yeah.
That this instead of being hydrofluoric acid, that's just the important part.
Oh.
Should be hydrofluoric acid.
Oh.
Because there's no chlorine in it.
Did he
I
not?
totally understand.
Thank you.
So on question number 12, I just want everybody to know it says hydrofluoric acid may be produced in the lab and used to etch glass. How many moles of hydrofluoric acid? That's just a brain fart by me because we use hydrochloric acid so often. So it should say hydrofluoric acid. That's all for question number 12. I'm going to give you another 2 or 3 minutes. Just finish up as much as you can. That's all I care about. Then we're going to move on to something a little bit more complicated.
No. I'm still stuck. If you give me your yes, you that's all.
No, we
That's all I'm thinking.
No, I got that. That's not a hint. That's already information that I understand.
I'm hinting at you the
John, the answer's on the list.
better. I'm hinting at how to solve that answer to the question.
But you're giving me the hint.
I'm gonna stop you if that's okay. As long as you got 1 or 2. Aku, are you giving me? Are you making sarcastic remarks?
No.
No. You seem sassy today. Goodness gracious. Okay. I'm gonna stop you there. We're gonna do these 3 problems relatively quickly. This first question, I apologize. It's just, I don't know, maybe I'm just gonna have to mess with the wording of it. So hopefully you got all these puzzle pieces. Then when we do our stoichiometry, right, looking for the mass in grams of calcium carbonate. So we can start with 100.09 grams of calcium carbonate over 1 mole of calcium carbonate. Then if we want to get rid of moles of calcium carbonate, we're going to use our molar ratio. 1 mole calcium carbonate for every 1 mole of calcium hydroxide. And we know we have 0.962 moles of calcium hydroxide. So when you put this into your calculator, hopefully you get 96.3 grams, do you? Yes, perfect, no problem. On the next one, the first step in the production of sulfuric acid is producing sulfur dioxide. So sulfur is burned in the air to produce sulfur dioxide gas. And so what would be the most complicated thing about balancing this reaction? What's the most complicated substance? Yeah, that's the sulfur dioxide probably. 8 sulfurs, so we need 8 O2s, no problem. So how many moles of oxygen gas? So we're looking for N question mark, right, number of moles, to react with 160 grams of sulfur, 160 grams of sulfur. So what I want to know is, in order to go from this substance to this substance, what do we need? The molar ratio. So the molar ratio is 8 moles of oxygen for every 1 mole of sulfur. But do I have the moles of sulfur? Are we given moles of sulfur right now? No, we're not given moles of sulfur. You have to find moles of sulfur, right? In order to get moles of oxygen, we need moles of sulfur because that's what the molar ratio does. It converts between the two. So, but I can take the mass, convert from the mass into moles using the molar mass. So did anybody calculate the molar mass of sulfur, S8? I know lots of people did. People just don't want to tell them. 256.56 grams of sulfur, right? Yep. Thank you. Oh, finally, one answer. Okay, so now I have everything that I need. We have everything that we need in order to do this. So we're going to take we're looking for moles of oxygen, so we'll start off with our molar ratio. Then we'll be able to cancel out moles of sulfur using the molar ratio, the molar mass, and then we'll be able to cancel out grams using the mass. So we are looking for moles, the number of moles of oxygen gas. So 8 moles of O2 for every 1 mole of S8. Now, I need to use the molar mass because this is the only other thing that has moles of sulfur in it, right? But how do I have to write this? Am I just going to take the molar mass and put it in here? Is that going to be effective for us to cancel out moles?
No.
No, it's not. So in order to do this properly, I've got to flip the molar mass. So 1 mole of sulfur for every 256.56 grams of sulfur. Now I've successfully canceled out moles of sulfur. And so I just need to cancel out grams of sulfur. Well, I know we've got 160 grams of sulfur. So grams of sulfur and grams of sulfur cancel out. And we should be left with 4.99 moles. Any questions? I'm asking you, is that relatively straightforward? Yeah. Okay. All right. Perfect. No problem. And then the last example, hydrofluoric acid may be produced in the lab and used to etch glass. How many moles of hydrofluoric acid may be produced by the addition of sulfuric acid to 7.81 grams of solid calcium fluoride? This is pretty straightforward. Does anybody even want me to go over this example?
No.
No. Yes?
No.
Yes.
Yes.
No.
No, maybe not. It's okay. It's fine. I don't know. I feel like I'm beating a dead horse right now. Okay. Now we are at proper gravimetric stoichiometry. If you want to convert from one mass to another mass, now I'm going to write something down. You can write it down if you want to, but it's going to take up a little bit of the room. If we have one substance, let's call it A plus 2B's gives you 5C's. Doesn't really matter. Whatever, it's not important. If I'm being given the mass of one substance, okay, so let's say I'm given 10 grams of this substance, and I want to find the mass of this substance. Some people are already way ahead of me right now. They already know exactly how they want to do this. But let's think about this. What's the only piece of information you're really being given in this particular problem, right here, right now? What's the only piece of information that is really, truly concrete to you? Wim? Okay. So we've got the molar ratio between A and C. And what is it? It's either 1 to 5 or 5 to 1. Doesn't really matter, right? As long as we understand it's the unknown over the given. Okay, so if I had the number of moles of this, then I could convert into the number of moles of this. Do you have the number of moles of A? Does it give you the number of moles of A? No. It gives you the molar ratio, but it doesn't give you exactly how many moles in real life right here, right now of A that we have. Do you know what I mean by that? Yeah, for every one of these, we make 5 of these. I understand that. But do we have one of these in real life? Or do we have 20? Do we have 3,000? Do we have 0.5? Who knows? We've got 10 grams. What do you need? What other additional information do you need in order to solve this problem? You need the molar mass to convert from grams to moles. Then you use the molar ratio to go from moles to moles. And finally, what other piece of information do you need? I can convert from grams to moles using the molar mass of this particular substance. Would you agree with that? Yeah. Then I can convert from moles to moles using the molar ratio. Would you agree with that? Now finally, I've got the number of moles in real life of compound C, or substance C. But I want the mass of substance C. So what do I have to use? I need the molar mass of substance C. This is where labeling everything is extremely hypercritically important for us, okay? And so you need to understand that here, if we're given the mass of this substance and we want to find the mass of this substance, we need 2 different molar masses. It's just the way it is. You need, in order to convert from moles of this to grams of this, or moles of this to grams of that, you need a molar mass either way. So I just want you to be aware there's going to be a lot of things when we write down our equation, we're going to have a lot of things summarized under the equation. The neater you can write, the better. The lazier you are, the worse this is going to be for you, okay? So let's try one example. That's all we're going to do today, one example, and then we'll do something fun tomorrow with jelly something or others. We're going to make jelly creatures tomorrow, like little jelly beans and jelly bears and stuff like that. What?
Are they edible?
Yeah, you can eat them. Once you make them, you can eat them. Is that okay? I mean, no, you can't eat them. No, you can't. You can't eat them. Everybody else can, but you can't. Okay. Because we'll be converting from mass to moles and moles to mass, we will need the molar mass of both substances. Example, calculate the mass of iron 3 oxide produced by the reaction of 500 grams of iron with oxygen from the air. You see these types of questions set up or worded this way? Calculate the mass of this thing produced by this thing. So our product is iron 3 oxide. Our product is iron 3 oxide, but the reaction actually involves iron plus oxygen. Now, if we wanted to balance this really quickly, it wouldn't be that bad. Oxygen is in groups of 2, oxygen is in groups of 3. So 2s and 3s, and then we need 4 ions. What it says, calculate the mass of iron 3 oxide. Mass of iron 3 oxide. The first thing I want to bring your attention to, if we want the mass of this thing, we're going to end up with moles. How can I go from moles to mass? Calculate the molar mass of iron 3 oxide. We may not finish this right now, but the faster you do it, the easier it'll be. So 159.70 grams per 1 mole of this stuff. So it's saying by the reaction of 500 grams of iron with oxygen. Okay, we're given mass of this stuff, but remember, we can only convert moles. That's the only thing we can do. So what do we need for iron? We need the molar mass of iron. So 1 mole of iron weighs 55.85 grams. And then, of course, in order to convert between the two, we need the molar ratio. We don't have time to actually write it down.
Students, please come to the office.
It'd be nice if you tried it for
Peter
tomorrow.
Sidman, Lama Zia, Matt Lewis, Nathan Jansen, James Griffith, Brooklyn Dunbar,
What?
Trevor Clark, Josh Burton,
Which one?
Rachel Klein, Desiree McCabe, Skylar Ray, Kate Rose, Jen Ansel, and Chantel Wiley.
Hey, did I tell you I'm not here on Friday? Okay. Have a good day.